Hello dear friends, let's do this question together. You see, this is a complex number question. 1 minus I or to the power of n. This is 2 to the power of n plus 2 over 2 times cosine of n times pi over 4. Okay, let's now start with our question. Assuming this to be z1 and this z2. So z1 here is 1 plus I, okay, and z1 power n, this is 1 plus I power n. We need to write this in its trigonometric form. So the modulus of z1 is equal to 1 power 2 plus 1 power 2. This is the square root of 2. As you see, this is 2 power 1 over 2. Okay, and the argument of z1 is equal to the inverse tangent of, we take this, the coefficient of I over the layer part. We have 1 over 1, and tan inverse of 1, this is pi over 4. So z1 can be written as the modulus, which is 2 power 1 over 2 times pi over 4 plus I times sine of pi over 4. Here is, and z1 power n, this is 2 power a half of power n into cosine pi over 4 plus I times sine pi over 4 all power n. And from the Moivre's theorem, we know cosine theta plus I times sine theta power n. And this is cosine of n theta plus I times sine of n theta. Okay, now z1 power n, this is 2 power n over 2 as you multiply these powers, cosine of n pi over 4 plus I times sine of n pi over 4. Here is z1. You see, let's look for z2. We assume the z2 to be 1 minus I. Doing the same, the modulus of z2 is the square root of 1 plus minus 1 power 2. Here is power 2. This is the square root of 2, and it's the same as 2 power a half. Okay, the argument of z2 is the inverse tangent of the coefficient. Here is minus 1. This is minus 1 over 1. Okay, the inverse tangent, this is tangent inverse of minus 1, and this is minus pi over 4. Okay, so z2 here, z2 is equal to, we take the modulus, and to this is 2 power a half into cosine of minus pi over 8 plus I times sine of minus pi over, here is 4 over 4. And you know cosine is an even function while sine is an odd function. This z2 is 2 power a half into cosine pi over 4 minus I times sine of pi over 4. Now, doing as we did on z1, z2 power 8, power n is equal to 2 power n over 2, okay, times cosine, here we multiply n pi over 4 minus I times sine n pi over 4. Okay, as you see, z1 and z2, both z1 and z2 have the same factor of 2 power n over 2. So taking 1 plus I power n plus 1 minus I all to the power of n, this is equal to, we take the z1 plus z2 power n, z1 power n plus z2 power n. Here we have 2 power n over 2 into cosine of n pi over 4 plus I sine n pi over 4. We are going to add this cosine n pi over 4 minus I times sine n pi over 4. Okay, this is equal, as you see, this and this have different sign, that's why they will cancel one another. This is 2 power n over 2 into this plus this is 2 times cosine of n pi over 4. As you see here, this is 2 power n over 2 plus 1, summing the powers, times cosine n pi over 4. Okay, so 1 plus I power n plus 1 minus n. This one is 2 by 2. This is 2 power n plus 2 over 2 times cosine of n pi over 4. Here is the proof. Thank you for watching. May God be with you. Before leaving, I want you to subscribe on my channel. Your like, your share, your comment is a great help. May God be with you, my friends.